And ever since then, so these disciplines have existed since that time. While software testing maybe 20 years, maybe 30, right? So we are still a young discipline, still a lot of opportunity. So that's what I want to talk about today. And that's why if you look at the topic, I put there 2006, right, to 2016, right? It's 10 years. And now why I use the last 10 years is because 10 years ago, the FedEx, FedEx is a big company in Memphis. It's a $54 billion company. It's a US $54 billion. And it's only about 45 years old, the company, right? So that company has been growing by more than $1 billion every year. $1 billion US every year, 4 billion ringgit every year. That's how fast it's been growing. It's still growing. You know what I mean? And for them, testing is very important. In 2006, they came to me and said, we want to develop a group that is world-class in testing. And then the CIO, Rob Carter, who's my friend, he took me on a FedEx plane. He says, we are going to Pittsburgh, to Carnegie Mellon University, because Carnegie Mellon is very famous for CMMI, right? So he took me on the FedEx plane, just the 2 hours in this big plane, right? Not many seats because it's a cargo plane, right?
Yeah.
We went to Carnegie Mellon, we asked the Carnegie Mellon people, tell us about the science of testing. They couldn't answer the question. They were not even looking at it. So when we were flying back that day, the same day, we were flying back, he told me, he said, Jasbir, you are going to set up, right, a testing group that's the world's best in software testing. And so now that group is called STEP. Most of you who come to this conference, you have heard enough about. The FedEx vice presidents have been here. So I set it up, and today that's the largest research group in software testing in the whole world, in a university. Microsoft has a software library group that is bigger than us, right? But in a university, we are the biggest. Because most universities, if you go to a computer science department, maybe they have 1 professor or 2 professors in testing at most. Right? So we are very big. So it's a STEP program. So to me, I've been involved. Now I don't run STEP anymore. Okay, I got promoted to do other things. So Robin Poston, my colleague, she runs the program that I set up many years ago. But we have been doing a lot of research for 10 years. So now I'm trying to put all the research together and say, what is the science? Can you see what I mean?
Yeah.
Right? So today's discussion is going to be about that. I'll show you some examples of the research we have done, and then you can think, how does that contribute to the science? Can you see what I mean? So we will discuss that. Okay? So now, that's what we're going to do. So we're going to go back and look at it again. Okay, let me figure this out. Okay, so I just told you the story about this, right? So when you do research to develop a science, many things are important. The first thing is what you guys do in the company, right? You guys work in company, right? What you do if, for example, if you are doing your integration testing before the unit testing, right? And then if your manager asks you, why are you doing that? You have to explain, right? So to be a manager, a good manager, you need to explain, right? You need to explain. Like the other thing I want you to do today. Later we will do some group exercises, right? Like in testing, how many kinds of tests are there? That means types of tests. How many do you know? How many do you think you know? How many type of tests do you know? Maybe 20? Maybe 10? How many do you know? I was teaching a class in the US, a testing class, right, for a large company, and one guy, so I give them group work to do. He came up with 143. Oh yeah. And then I said, do you do all the 143 for every system? Oh no. Right? You know 143 in his case. He only applies about 25 to a large system. And the process of taking 143 and picking the 25 most important one, we call it test planning. You can see that's called test planning. You as a manager, when are asked to justify, for that system, these are the tests you're going to do, your test plan. Now, somebody may ask, oh, what about these other tests? Right? And then your duty is to say, no, I'm not going to do that for this reason. Or yes, I'm going to do this for this reason. Right? Are you joining the tutorial? Oh no, sorry. Here. Right? You came to take your pictures. Okay? Right? So that's very important. When you explain, you are contributing to science. You can say when you work for a company, when you explain, when you stand in front and say, this is the test plan, you have excluded some kind of tests, you have included some kind of tests. That is the science. That is helpful. So later we will, once I give you some material background, then we will do a test like that. Right? We will try that. Now the other thing is, when you take 143 tests and you just pick a few, what is the method for organizing this test? What is it that holds it all together? Right, like if you play football, right? If you are the coach, you will say, "Oh, I play 5-3-2." Right? Like when I was a young man here, I grew up in PJ, right? I used to play a lot of football, right? At that time, all the soccer teams were 5-3-2. 5 forwards, 3 midfield, and 2 defenders, and then goalkeeper. Now got 4-3-3, 4-2-4, right? So how do you hold all the players together? That's strategy, right? That's also part of the science. Right? And for you, if you want to become a good IT manager or testing manager, being able to explain and justify your decisions is very important. Right? Not one is to yourself. When you put your test plan, you justify to yourself why I'm doing it. And then justifying to others is very important. Right? So, and the more you can learn that, the more you learn how to talk to other people. Right? Say, I've done this test plan, and this is why I picked this, and this is what the order in which I'm going to test. Right? So you must get used to talking about it. The more you do it, the better it will become clearer in your head. And it will be better, it will make you you'll get promoted faster because you understand why you're doing it. Otherwise, somebody give you a test, you just do, right? That gila anybody can do, right? So, but being able to think deeply is very important, right? So for the science, so what you do in company, just like at FedEx, right? They wanted, whatever they did there, they wanted to be informed by research. They don't just want to say, okay, we do it like this. If someone say why, you must be able to explain. So they wanted that. Right? So the research can be both theoretical and also applied. Right? Theory work is like, you conceptually put a plan together, right? While applied means you actually go and do. Can you say, both are important. You can't just say, I only have this and not that. If you only have one and not the other, you cannot develop a science. You cannot develop a science, right? Every theory needs to be tested, right? So, but what happens here, what happens in our industry, testing, is because we don't have a science, right? People are doing things their own way, right? And sometimes there's no logic or theory behind it. Like I was telling you about exploratory testing, right? There are exploratory testers who will come and tell you, oh, you shouldn't have a system. You should just go there and try to break the system. You don't need science. One of the exploratory testers told me, I don't need science. I'm a good tester. I can break it. I'm a good tester. That's not good, because that means you got no theoretical concept to explain. But I can break. I try here. I poke here, poke there, and then suddenly, I find effects. Can you see me? That's a very dangerous way to test. It's a dangerous way to test, and it's not a good way of building a science. Can you see what I mean? So sure, we all do exploratory testing. Sometimes you do it because it's fun, but it can be very frustrating too. When it doesn't break, you don't find anything, right? Or it's broken and you don't know why. It's very frustrating. So testers lead a very frustrating life. Can you see what I mean? Right? So, but don't believe if someone says exploratory testing is all you need. Don't believe them, right? You need a system, structured way to think about it. Right? Now, when you want to build a science, right, there are two things playing with each other. We call it induction and deduction. Who knows the definition of induction and deduction? Who's the expert here? Induction and deduction. A deduction, deduce always starts in your head, right? You've got an idea, aha, and then you go and try it, right? So when you go from your head down, that's called deduction. Testers have to be very good at deduction. You get a system to test, a module to test. You can say, let me try this. Even the exploratory tester will say, let me try this. Why? Because I think usually I tested a similar system 20 years ago and I found the defect here. Remember, that's deduction. You are starting in your head and then, now, so testers have to be very good at that, but the opposite is induction. Induction is when you start with the data. Right? Oh, this system, this code is written this way, right? There's a logic gate here, and it doesn't make sense to me. So remember, you start with the data. That's called induction. From the data, then you say, wow, the defects are always between the interfaces in the modules, right? It wasn't your idea first, say, defects always, interfaces are always where the defects are found, right? If you had the idea and then you find it, that's deduction. But if the data shows you, and then in your head, you learn something, you can say, interface defects are the most number of defects in the world. Can you see what I mean? So then you're going from the data. So what your mind is doing when you're developing a science is you're doing both induction and deduction. And usually in the cycle, first you have an idea, then you try it. When you try it, got defect or no defect, remember it's a result, it's data. That gives you an idea, so it goes in cycles. You start with deduction, then you get induction, then you get deduction and induction, right? So both the methods are very good, and if you're a tester, you want to develop both those skills. Every time you do a test, whether you find a defect or not, you are getting information. Every time you try something. It's important, right? So it's not only you find a defect and, I found a defect, right? In FedEx, in the early days at FedEx, if you found a defect, you got $40. They paid you. The more defects you find, the more money you get. So the testers were very motivated. Can you see what I mean? So sometimes they even they make friends with the developer. They say, okay, you just put some defect. I find them, then we go makan together, right? And you pay because you get paid for the defects. In the old days, they used to do that. Yeah, absolutely, right? And but think about that. Think about that and say, is that a good way to build a science? Induction and deduction, right? So develop both the capabilities, right? So maybe you keep two lists. When you are given the responsibility, here's a system to test. The first thing you do is say, look at it and say, okay, based on this, I'm going to do this from your old logic, right? And then look at the system and say, what are things I have to test? Because the system will tell you something, but then you need your own methodology too. Right? So let me tell you another story. Is some years ago, I was asked to serve on the like companies will hire test managers, right? I was asked to, by a headhunting company, right? They wanted a very senior manager for testing. They asked me to help them select people. So they gave us about 50 resumes of people who had applied, right? Then together with the company people and then me, I was the outsider brought in to provide input. And then we shortlisted to about 10 people, then we interviewed the 10 people. And then we make a recommendation, and they want me to give input. So every single person we interviewed, I asked them, what is your personal methodology for testing? Right? And most of them told me, I don't have one. Whatever the company has, I will do. Oh yeah, right? Now that question is a very important question for you to know. If you are going to be a test manager one day, you must have a philosophy. You must have a philosophy. And that is based on deduction. Right? Over many years' experience, you say, if I have to do a test plan, this is how I do it. I always do this because I know how to find it. And then you also look at the system. Then you say, this kind of system always break here. This kind of system always break there. Right? Like if it's a weaponry system, you know if this one doesn't work, the war fighter will die. Just a minute. So I better check that. You know. Now, how do you know? Because you know that system is going to be used by a soldier. You see what I mean? So you spend more time testing there because you don't want somebody to die, right? Especially your own soldier to die. You see what I mean? So now that came from the system. Remember, it's not part of your thinking, but it came from the system. Okay? So induction and deduction are both very important. So you can even keep two separate lists the next time you're given a system to test.